Om Sri Sai Ram. Hearty welcome to the chapter on metals. As you know, metals are very important elements which are very essential for our daily life also. And you should know some chemistry of metals. We know some physical properties in the last class, and also we have studied about ionic compounds. Now we will see some extraction of metals. Before that, we will go through the home assignments what we have given last time. The first question was, when zinc is added to ferrous sulphate, what will happen? There will be a displacement reaction, and the reaction will be Zn plus FeSO4 gives ZnSO4 plus Fe. What is Zn? Zinc. Zinc plus ferrous sulphate gives zinc sulphate plus iron. So, this is a displacement reaction. Similarly, two type of the same type reaction we have studied in the last class. Okay. Second question is, write the electronic dot formula of sodium. As you know, sodium contains 11 electrons. First orbit K shell you have 2, L shell it has 8, and M shell it will have 1. So, last electron in the outermost orbital is 1. So, 2, 8, 1 is a configuration. In case of oxygen, it is a non-metal. The atomic number is 8, it has got 8 electrons. First orbital you have 2 electrons, second you will have 6 electrons. That is what you can see in the figure. Lastly, magnesium is a metal, very active metal, atomic number 12. Atomic number is nothing but number of electrons or protons present in atom of an element. And here there are 12 electrons. First orbit you have 2, second 8, third is 2. So, outermost you have 2 electrons. Okay. And next, third question is, write the electron dot formula of sodium oxide and magnesium oxide. So, we will see little details about that. I will show in some details about that. So, sodium oxide formula is Na2O. It is formed by the combination of sodium and oxygen. As you know, sodium has 1 electron in the outermost orbital, and 2 atoms of sodium combines with 1 atom of oxygen to form sodium oxide. So, this is the electron dot formula of sodium oxide. To go little details, we have, see, this is called K shell with 2 electrons in the first shell. Then you have 8 by Bohr's formula, you know, we have studied in class 9th, 2n square formula. First shell is 2, second shell is 8, third shell is 1. So, here 2, 8, 1. This is called outermost electron. So, that is what is represented as the dot here. And if you break the steps, 2 sodium atoms lose 2 electrons which are in the outermost, and it becomes sodium ion. When you write plus here, it becomes ion. It is called as cation. So, 2 cations are produced from sodium. The ions released by sodium is taken by oxygen. Coming to the electronic configuration of oxygen, first orbit you have 2 electrons, second you have 6 electrons. So, the electrons given out by sodium is taken by oxygen. So, oxygen takes 2 electrons, then it becomes oxide. So, these two together, sodium plus oxygen becomes sodium oxide. It is an ionic compound because it is formed by the combination transfer of electrons. The electrons given out by sodium is taken by oxygen to form what is called as sodium oxide. Similarly, magnesium oxide, it is also ionic compound formed by the transfer of electrons. Here magnesium has 2 electrons in the outermost orbital, 2, 8, 2. Last shell it has 2 electrons, and oxygen has 6 electrons. These two during reaction forms magnesium oxide because to form what is called as octet arrangement, it wants to become stable. How do they become stable? Magnesium loses 2 electrons to form magnesium ions. Oxygen gains 2 electrons to become oxide, and hence magnesium plus oxygen gives magnesium oxide. It is a ionic compound. That is the dot formula. The ions present in sodium oxide are sodium ion and oxide ion. Magnesium oxide, the ions present are magnesium ion and oxide ion. And last question is, why do the ionic compounds have high boiling point? As I told yesterday, last time, boiling point is the point of temperature at which the compounds or liquids boil. And as you have melting point is nothing but the point of temperature at which the solids melt. Okay. Here we say that the boiling point of ionic compounds are high because they are bound by the strong electrostatic force of attraction between the ions. These ions are bound by the strong force. Therefore, lot of energy is required to overcome these forces. Okay, that is all the homework. I think most of you have done it. If you have not done it, at least now you complete off. Okay. Now coming to today's topic, that is called occurrence of metals. So in the last classes we have seen something about metals. Now we will see how does it occur, where does it occur, how to extract metals from the compounds of the metals called as minerals. First one is minerals. Minerals are the compounds of metals that are found in the nature in the combined state. Combined means what? In the form of compounds. Even sea water also contains sodium chloride, magnesium chloride, etc. They are the compounds of sodium and magnesium, right? So metals are found in nature in the combined state. And of course, when you say it is available in earth crust, it is naturally, it contains lot of impurities also, like rocks will be there, or sand will be there, and many other things will be there. And but we have got what is called as ores. Ores are nothing but mineral from which a metal can be extracted profitably. See, many of the minerals contain lot of metals, and percentage of metal is be more. So if you extract metal profitably, for example extraction of gold, it will be native form, and it will be a very huge process because there will be lot of quartz material and rocks and all. So it is a very huge process, a long process, but in other cases it is not so. Anyway, all ores are minerals, but all minerals are not ores, because minerals means it invariably contains sand or rocks and other impurities, right? And earth's crust, it is called as the storehouse of the metals. And in many places, if you go to even Karnataka also, there are a lot of places where these minerals are found. If you go to Ballari, you will have a lot of mines there. We call it as mines. If you go to KGF, you have gold mines. So, seawater also contains some soluble salts such as sodium chloride and magnesium chloride, etc. That is why if you taste the seawater, it will be very saltish in nature, because the major content is sodium chloride. Now, coming to extraction of metals. What do you mean extraction? Taking out. How to take out? For that, we have on the basis of reactivity, we can group the metals into 3 categories. As I told earlier, some metals like gold, platinum, etc. are obtained in the earth's crust in the native form, free state. If you go to KGF, you can find a very beautiful, very interesting mine there, and you have to go something like 5,000 feet down. Very interesting experience. Of course, you will not be allowed, only seniors above 18 years they will be allowed. You have to go down, and as you go down in the mines, you will have a very beautiful experience, because the temperature increases, pressure also increases. You have to go down in the lifts, and there will be no oxygen supply. They have different devices for getting oxygen and water also. So, beautiful experience, and you will be given with a helmet and a light also, because you have to go into deep mines. A very nice experience to go into the mines. Okay, in later stage you can also go, and that is how gold is extracted. The ore of course, it is not a ore, it is a sand only. It is called as quartz. So, tons of quartz are smashed into small pieces of gold, and earlier it was getting about 2 kgs in KGF. Now it has reduced, and almost the mines have been stopped. Only one place in Karnataka is Raichur, Hatti, where you get gold now. Similarly, there are different ores, like for example, ore of aluminum is called as bauxite, ore of copper is called chalcopyrites or cuprite, and ore of the manganese is called magnesite, and ore of different aluminum is called as bauxite, and so on. Chromium is called chromite, and so on. So, all these are what is called as ores, from which we have to extract the metals in a profitable way. Okay. And for removing these metals, they are grouped into 3 categories. The first category is called metals of low reactivity, because elements like gold, platinum and silver, they are very less reactive, because of number of electrons in the outermost orbital decide the reactivity. So, those of less reactivity, that is number 1. Number 2, metals of medium reactivity, and like zinc, iron, copper, etc., they are the metals of medium reactivity. Lead also. And next one is metals of high reactivity, like potassium, sodium, calcium, magnesium, aluminum, etc. So, there are different steps involved, and let us see what are the different steps involved in the extraction of pure metals from ores. The first step is called enrichment of ores. Enrichment means what? Improving the quality. For example, you have experience of drinking coffee, right? And some wants strong coffee. What means strong coffee means what? Strong coffee means contains more of decoction. Some want light coffee, means decoction must be less. Okay, like that you have enrichment of ores. So, enrichment means first of all the unwanted material is to be removed. What is unwanted material? That is called as gangue. The impurities present in the ores such as sand, rocks, etc. are known as gangue. These impurities are removed by suitable methods. For example, in case of iron, they pass a stream of water, strong stream of water is passed. So, all the unwanted material like gangue is removed. So, different methods, some in case of some metals you have heating, some magnetic separation and so on. So, gangue is separated, and next step is extracting metals low in the activity series. Just now I told you there are 3 series which are low in the activity series. Low in the activity series means they are not so much reactive. In this case, for example, mercury is one such, copper is also one such. Here what you do is, oxides of these metals can be reduced to metals by heating. For example, the ore of mercury called as cinnabar, CINNABAR, and it is also called as mercurous sulphide, HGS, and mercuric sulphide, HGS. There are 2 valencies for mercury, one is called 1, another is 2. If we have 2 valency, it is called mercuric. If you have 1 valency, it is called mercurous. This is called mercuric sulphide. The ore of mercury is to be heated in 2 stages to get mercury. The first stage is heating of mercury, namely nothing but cinnabar. When you heat it strongly in presence of oxygen, HGS plus O2 gives HGO plus SO2. What is SO2? SO2 is nothing but sulfur dioxide. When you balance the equation, it becomes 2HGS plus 3O2 gives 2HGO plus 2SO2, and SO2 is released outside, and that is how mercuric sulphide is converted into mercuric oxide. So, HGS is converted into HGO. Here mercuric sulphide is oxidized into mercuric oxide, and oxygen is reduced to sulfur dioxide. And coming to next reaction, this mercurous oxide is again heated so as to get mercury plus oxygen. And if you balance the equation, we have 2HGO gives 2Hg plus O2, that is a decomposition reaction. Earlier it is displacement reaction, and this is a decomposition reaction where a compound like mercuric oxide is decomposed into mercury and oxygen. I think all of you, what kind of metal is a mercury, right? It is a only one metal which is liquid in nature. It is flows, it is very heavy also. It has got a shining luster, very peculiar. Density is very high, 13.6. That means if you put mercury into water, it sinks down because density is very high. Now, we shall see one more metal, namely copper, how it is reduced into copper from its ore. Okay. Similarly, in the case of copper, the ore of copper, cuprous sulphide, when it is heated strongly, it becomes cuprous oxide and sulfur dioxide is released. And when that oxide of copper is heated with the cuprous sulphide, it forms copper plus sulfur dioxide. It is a similar type of reaction here, and here if you balance it, Cu2S, so 2 2s are 4, and here 2 2s are 4. Oxygen is 6 here, 2 plus 4, 6. It is a balanced reaction, and this is again a displacement reaction. So, cuprous sulphide is converted into cuprous oxide, and when cuprous oxide reacts with the undissolved cuprous sulphide, it gets reduced into copper, and then you have sulfur dioxide gas which goes out of this. Of course, this heating and all not done by ordinary methods. We have big kilns, huge kilns are taken, and in that kilns lot of temperature is produced, and during that heating only it should be done, because otherwise it won't the metal will not be extracted. So, this is one of the methods of extracting copper, and we will see one more, the different methods extracting metals in the middle of the activity series. And here you have iron or zinc or lead, etc. These metals are moderately reactive. So, even in a class also, some boys will be very bright. They will grasp so quickly whatever you say, immediately one shot they will understand. But there will be very weak students also who cannot grasp one time. Then 2 times, 3 times, 4 times you must go on repeating. And of course, there will be so many factors for that. It is not a mistake. There are so many aspects are involved. There are some boys who know that too intelligent, not too dull. They are in the middle, and they will grasp by twice or thrice. If you tell, they will understand easily. Okay. So, like that, it is called moderate. Neither too active, nor too dull. The middle one is called as moderate. That always it is said that the middle path is the best path. Some will do very fast, the work will be done very fast, and when haste is waste, there will be some mistakes also, and there will be lot of, and there will be so dull also, it is also not good. The middle path is always good. Okay. Now, these metals which are moderately reactive are present as sulfides or carbonates in nature. The ores of these metals are called as sulfides, sulphids. So, you know the difference. Sulfide, its formula is S. Sulfite, SO3. Sulfate, SO4. So, note the difference. Spellings also correctly note. This is sulfides. And carbonates, formula is CO3. So, you get the sulfides and carbonates in nature. These are to be converted into metals in 3 stages. The first stage is called roasting. Roasting means the sulfide ores are to be heated strongly in excess of air. Excess means what? More air is to be blown. So, for example, in case of zinc, if you take zinc sulfide is the ore of zinc, it is to be heated strongly in supply of air, it becomes zinc oxide and sulfur dioxide is released. This method of converting the ore into its oxide, sulfide into oxide by heating strongly is called as roasting. And what is the second step? Second step is calcination. Suppose you have the ores in the form of carbonates. For example, the ore of zinc is also zinc carbonate. So, if the carbonate ores are there, they are converted into oxides by heating strongly in limited air. So, what is the difference between that calcination and this one? There you have strong supply air, here limited air. And in case of zinc carbonate, it converts into zinc oxide and carbon dioxide is released. So, what is the first step? Converting the sulfide ores and carbonate ores into respective oxides. How it is done? By passing oxygen. In case of the first case, you have more quantity of air. Here it is limited quantity of air. Third step is reduction. You have studied that reduction and oxidation in chapter 9th class. Oxidation is a process where oxygen is added or hydrogen is removed. Reduction is a process in which oxygen is removed and hydrogen is added. Okay. Here you see, for reduction, the elements like coke is used, the form of carbon. Coke is a very good reducing agent. What does it do? It converts the oxides into the respective metals. For example, in case of zinc, we have zinc oxide. It is a solid. In the presence of coke, if it is heated, it is a reducing agent, reduces zinc oxide into zinc, and carbon monoxide gas is released. And of course, this is inevitable in all these metals. When they are extracted, the nearby area will be polluted by, just I am telling about mercuries. There also gases will evolve. In case of copper also, here also carbon dioxide, carbon monoxide, both are not good for health. So, carbon monoxide is poisonous. That is why all factories should have trees around the factory. The whole area must be greenery, because it may pollute the atmosphere, it may cause ill health for the persons who are working nearby. So, here these are the 3 steps. So, the first step is roasting, heating in excess of oxygen. Second step is calcination, suppose it is carbonates. Third step is reduction, where the respective oxides are converted into metals. And we will see one more example with the same type, wherein the metals can be extracted in the same type, and of course, these are the 3 important process of converting the respective ores into metals. We will see one more example. In case of metals like manganese or iron, etc., there is a slight change. Instead of the reduction reaction, you have what is called displacement reaction. For example, in case of manganese, Mn is manganese. Please note difference between magnesium and manganese. Both starts from M only, Ma, that is magnesium is Mg, manganese is Mn. 3 MnO2 means manganese dioxide plus aluminum gives, or it is reduced to manganese and aluminum oxide. It is a displacement reaction, and if you balance it, you have 3Mn, 4Al, 4Al and 6O and 6O. So, this is a displacement reaction. Here manganese will be in a liquid form or molten form, and another one is in the case of iron, ferric oxide, that is also called as magnetic oxide, Fe2O3 plus Al. Here aluminum is used as a reducing agent. So, it reduces iron oxide into iron, and aluminum oxide also is used. So, here ferric oxide is reduced to iron, aluminum is oxidized to aluminum oxide. So, that is also possible. So, this is also what is called as displacement reaction. And coming to some home assignments on this chapter, we have the first question: define the following terms: mineral, ore, gangue. Second one, name 2 metals which are found in nature in the free state. Third one, name the chemical process obtained for a metal from its oxide. You have to name it. Fourth one, aluminum is highly reactive metal, yet it is used to make utensils for cooking. Why? Fifth one, carbonate and sulfide ores are usually converted into oxides during the process of extraction. Why? See you next. Thank you.